Good morning, this is Mrs. Wyrick, and today we're looking at Unit 6, Lesson 2, Factors and Primes. Now, as a reminder, factors are those numbers that when I multiply them together give me a product. So some factors of 12 would be 1 and 12, 2 and 6, and also 3 and 4. Those are my pairs of factors. And when I put them in numerical order, they would be 1, 2, 3, 4, 6, and 12. Now let's take a look at the factors of 27. 1 and 27, and also 3 and 9 are factors of 27. When I multiply 3 and 9 together, I get 27. When I multiply 1 and 27 together, I also get 27. Is something called a factor tree in math. And a factor tree is actually a graphic organizer to show you the factors of a number. It only shows you in the end result all the prime factors of a number. And that's what we're doing a factor tree for, is to find the prime factorization of a number. In order to do that, first we need to start with two factors that we're familiar with for the number 48. Two numbers I need to multiply together to get 48 are 6 times 8. How about that? 6 times 8. All right, now, when we use a factor tree, if one of our numbers is prime, we're going to go ahead and circle it. And we're going to expand our factor tree until all of our factors in the end are prime. Do you see any prime factors here? Is 6 prime? No. It can be divided by something other than 1 in itself. How about 8? Can it be divided by anything other than 1 in itself? Yes, it can. So those are not prime. They are composite numbers. So I'm going to go ahead and branch out the 6 to have more factors, and also the 8 is going to have more factors. Now factors of 6 are 2 and 3, and factors of 8 are 2 and 4. Now 2, even though it's even, is a prime number. 3 is a prime number, and this 2 here is also prime. It can't be divided by anything other than that number and 1. Now 4 has a couple of factors other than 4 and 1. Its factors are 2 times 2. And those are both prime. Now, to write our prime factorization, we're going to write each one of the factors that we see just once. So I see a 2 here and a 3 here. So I'm going to write a 2 and a 3 over here in this area. Now remember, I said that factors are multiplied together. So we need to show that we're multiplying those two factors together. And last but not least, now we need to count how many number 2's we have that we're multiplying together. 1, 2, 3, 4. 4 number 2's, so that means I need an exponent of 4. We have 4 number 2's being multiplied together. How many 3's do we have? Just 1, so do I need to put an exponent of 1 up here? No, I don't. I understand that this is 1 number 3 right here. So your prime factorization for the number 48 is 2 to the 4th power times 3. Take a look at factor tree for 100 and see if we can find the prime factorization for 100. 2 factors of 100. 10 times 10? Yep. 10 times 10 equals 100. Is the number 10 prime? No, it's composite. It has factors other than 10 and 1. So its factors are actually 2 and 5. Well, that's easy. 2 times 5 on both sides. And 2 and 5 are both prime numbers. Their only factors are 1 and that number. So now I need to look at my factors. How many factors do I have here? A 2 and a 5. All right, those are my different numbers. A 2 and a 5. Remember, we're multiplying them. Now count your number of 2's. I see 1, 2, 2 number 2's, so I'm going to give an exponent of 2 here. Excuse me, and I see 1, 2, 2 number 5's, so I'm going to put an exponent of 2 here. So my prime factorization of 100 is 2 squared times 5 squared. Let's prove that. 2 squared equals 2 times 2, which is 4, and 5 squared equals 5 times 5, which is 25, and 4 times 25, or 4 quarters, equals 100 cents. So 4 times 25 is 100. That means that my prime factorization is correct for 100. Now let's go back to the board and try some problems.
Made with Doodlecast Pro.